I guess we hope we're going to enjoy final the way we had a good time with the midterm. So we'll discuss it next week. And right now I'd like to see what we did last time for a quiz. And let's see what was the exercise. Number 6 or something like 6, right? Or something else. I'm trying to recall. So I know somewhere 6 or let's see, 7, 8, probably number 9. Oh, 11. Thank you. Thank you. See, there are lots of little questions, but they're actually nice little questions. Thank you for keeping track of this. So let us start. Exercise 11 wants us to set the hypothesis that says mean amount of coke in cans is at least. So mean is not less, it could be greater than or equal to 12. Well, that's what the can says, right? So it's 12 ounce, so they better put not less than 12, so at least, and that statement needs to be in H index 0 because it has equal sign in it. So that's the only thing that we saw here in the section that we just need to make sure that whatever is with equal sign goes to H0. I think it'd be a good idea to actually move to the section and do a problem where we can apply all of these settings. And that's why I want to move to section 7.4. And I will do 7.3 after that. I think that 7.4 is somewhat familiar because it deals with z-scores for the mean, and that's our, I guess, old favorite little formula that we used so much, right? So let me grab the exercise and do it. So I'm going to the section and then see how we can set up various hypotheses. Let's say start with exercise number 9 that talks about Everglades temperatures. So they're trying to monitor the ecological health, and they say the bottom temperatures recorded in some station with the average of 30.4 obtained from 61 temperatures. So number of temperatures in is 61, and the average, which is mean, right, for that sample of 61 temperatures, happen to be 30.4. That's a great start. So then they say a standard deviation is 1.7. Okay, 1.7 is a standard deviation here. So we need to test the claim. That's the key part. The population mean is greater than 30. So what they're claiming here is that mean for population is called mu is greater than 30. So they spelled it out, and they always will. So they're always going to clearly state what is that they're claiming. So you may agree, may not agree. Some people may say, look at this, it's actually greater than 30, so the probably claim is supported. Well, let us check it out. So we have to set this H1 and H0 hypothesis. And since I don't see the equal sign here, I must put it in H1. Because H0 always has equal sign. And H0 is going to be the opposite to H1. They always are opposite. So that would be less than or equal to 30. And we have our start. So we're going to make a picture and see what is happening here in this exercise by taking the picture of H1 that we always make a picture of. H1 is here. That's the area for H1, and H0 is the opposite, so that's always big. And there is a cutoff place right there in between. So what we need to do is to test this claim with 0.05 significance level, which means that area that we are going to have for H1 is 0.05. Area 0.05 for H1. For H0 will be always the opposite, which is 95. So total is 100%, 5% for H1, 95% is for H0. Why do I need that 95%? Because I'm going to the tables. I need to know the cutoff number here. And once I get into this favorite Triola tables and formulas, then in this choice, I have this normal distribution tables and need to find 0.95 in it among the areas, right? So the positive z-scores is what I'm looking at right now. And I need to get 0.95. So where is that number? It looks like it's right there. Remember the asterisk points to it, that special number. So we're exactly in between of 94.95 and 95.05, right? So that's what this asterisk actually reminds us of. And the arrow brings us down here to area 0.95 and to z-score of 1.645. So this is my cutoff value for z-score. So if I'll be to the right from it, I'm in H1. If I'm to the left from it, I'm in H0. So how do I get whether I'm to the right or to the left? Well, now I'm going to calculate the favorite z-score. And that's our formula that we always utilized, right? So I just need to put 4 numbers in that formula. And they always give it to us. So the mean is 30.4. That's for the sample. Now we also need to get the population mean mu that always comes in H0. So it's 30. Let's say, is that less than 30? Well, we always take equal. We always take the border value, that's standard. 1.7 in my denominator that I have to divide by square root from 61, that's my sample size. And once I have this placed here in the formula, then I need to use a calculator and see what the actual z will come out to be for the sample. So I need to go for the scientific calculator, right? Scientific calculator. And I need to get the parentheses, right, around numerator and denominator. That'd be always a good idea. So 30.4. Try to enter it with me. I think we had a few quizzes that we practiced to put these numbers in a calculator, and some people had a little bit of a difficulty. So I would recommend that you enter these numbers just like I do right now, simultaneously, and make sure that you get the same answer. which is 1.83 ... And that's the key moment on this exercise, because I must make decision about my claim. So that Z 1.8, notice it's going to be someplace here because it's greater than 1.6, because it's 1.8, right? 1.8 is greater than 1.6. So I just hit area called H1. So I say yes to H1. And automatically I say no to H0. And what I just did, I supported their claim. Notice that we just made a big statistical finding. We supported the claim they made that the temperature, the average temperature in that area is greater than 30 degrees in Celsius. For some reason, they want to go with Celsius, whatever. But the point of story is now we statistically proven that the temperature is more than 30 degrees, the average, and whatever follows from that, now you can actually utilize that fact. And that's really important. So we testing hypothesis, and we need to, I guess, follow this same process pretty much in every single exercise. So let me do another one. Exercise number 11. It says cutting in levels of smokers. Okay. They take 40 smokers sample in exercise 11. And then they have the mean and standard deviation here for us. Let me write this. So sample mean came out to be 172.5. And then we also have a standard deviation as a 119.5. Okay. What else? Now they say use significance level of 5%. That'd be the area of that tail H1 to test the claim that mean value is equal to 200. Again, the key part here is claim that says mean, which is mu, right, is equal to 200. So that's the start of our exercise. So now I need to put this H1 and H0. And where does the claim go? H0 or H1? And the answer is equal sign is here. If there is an equal sign present, it's always an H index 0, because H1 does not have equal sign. That's how we always set it up. It does not have equal sign. So the opposite statement to the equal will be not equal. And not equal means it's either greater or less than 200. We don't know what it is, but we're just trying to test if it's equal or not. And I'm going to make a picture of that H1 region. And I noticed that this region H1 is now going to be split into two equal pieces. So my H1 is actually contained on the left and on the right side. And H index 0 will be everything in the middle. So if H1, or they call it as a significance level, is 0.01, then area here will be 0.01 divided by 2, which is 0.05. And the same on the other side, 0.05 is also area on the other side. So a picture is always symmetric. So if I find the area that corresponds to 0.005, that should be enough, because on the other side it will be same but with a opposite sign. So I'm going for the previous table. I need 005. Remember where it is located? It's also with asterisk. See, those are very popular numbers that we keep on visualizing in our tables. So 005 is right in between of 51 and 49. It's like 50. And that's why the asterisk actually brings us down. And it actually shows 005 with a z-score negative 2.575. So let me write it here. The critical value, the border value, negative 2.575. And on the other side, since picture is symmetric, it's going to be positive 2.575, just like that. So I found the two special numbers here. So I'm going to now go for the z-score, use the same formula that we just utilized in a previous exercise, and get some number. So we have here mean, standard deviation, sample size, and population mean. So let's put them in our formula. Let's just do it carefully. Numerator that we usually put in the parentheses, right? In the calculator, and then denominator 119.5 is divided by a square root extracted from 40. That's what I need to enter in my calculator. So I just want you to start realizing that problems are the same. The calculation is the same. The end result is always going to be of the same type. So let me put this parentheses. 172.5 minus 200, right? In the parentheses, divided by another parentheses, 119.5 minus, divided by that square root and denominator. Need to be careful, square root of 40. And this is it. We've got a z-score, and that's great. So the negative 1455 ... I need to decide where it's going to be located with respect to H0 and H1. What does this mean? Well, we just have to check and see which region this negative number is going to be in. And since that region has a border of -2 and something, then we are not getting that far from 0 because it's just -1.4. So H0 area, I say yes to it and automatically deny H1. So we just statistically proven that H0 is correct because we supported it. We said yes to H index 0. And this is it. This is supporting of our claim. So it looks like we always need to start the same way. We need to put H0, H1 and make a picture of H1. And the next step, get this border value or values depending on the two-sided or one-sided type of claim. And then need to decide about z-score, if it falls into H0 or it falls into H1. So the key part, I guess, it's deciding if it's one-sided or two-sided. So let us practice without solving problems to actually make such a decisions. So let me maybe scroll down a little bit and do some of these just hypotheses, one-sided or two-sided. What about problem number 10 here? They're talking about the claim that population mean is less than 200. So once they make such a claim that mean is less than 200, it's going to be one-sided because we're only on the left side, on the smaller side. You see how it works? So you need to decide one side or two sides. So when is two sides going to happen? Well, in exercise number 11, where we had equal. Because once you have equal and not equal, then it's going to be two-sided. Why is it two-sided? Well, look at the picture. You have on one side and on the other side. You see the region on the right side that I'm highlighting, and then the region on the left, because equal, not equal is two-sided, because not equal means either greater or less. So equal, not equal is two-sided, and greater or less is one-sided. How about exercise number 12? That says, again, claim here that equal to 40 centimeters. In exercise number 12, our claim says equal, right? Mean is equal, so it's going to be two-sided, because equal means the opposite is not equal, so it'll be either less than or greater. So equal means two-sided, not equal or less is one-sided. Same with exercise number 13. Notice that claim says not equal. You see, in exercise number 13, we again have two-sided. I say, Alex, but it doesn't say equal. It doesn't matter. We have not equal. And not equal and equal, they both belong to two-sided hypothesis. 908. So how about if you tell me one-sided or two-sided? I think that'd be interesting if you take a look at the exercise number 8. So tell me here, we have equal to 46,000. So for a quiz, I'm wondering, is this claim one-sided or two-sided? Just like we did a couple of previous exercises, it's pretty much same thing. So don't need to do any solution, just tell me for exercise 8 claim, one-sided or two-sided? Maybe next time I'll do this actual exercise again. Advice is look at problem number 12, problem number 13 with that equal, not equal story. And I guess that's all we need. A little quiz in here.